Hi, everyone. Are you ready for the last talk of this amazing conference? Hey. So I'm going to talk about wrapping things up. Sorry, I'm not going to talk about burritos and wrapper, but you had a great lunch to get to that. So I'm going to instead provide you some food for thought, hopefully. So let's start with a basic example of what we might want to do in today's Swift, like even in Swift 4 today. There is some kind of maybe model object that you have in your application, in your code, and some of the properties that you have, you might want them to have some kind of specific behavior, like progress, for example. Here, you want every time you set a value for your progress property to ensure that it's actually between 0 and 1. So one way to do that in Swift is to use get, set, did set, will set. So here, if we use did set, the behavior is that when you assign a value to movie.progress, like 42 here, the did set will automatically run and will replace that value with the clamped value between 0 and 1, so 1 in this case. So that's all nice and well, and that works great. The problem is then you have volume property that has the same behavior, and you have to repeat that. So of course, you're going to copy-paste, and you're going to forget to replace self-progress with self-volume or something like that. So it's easy to make mistakes at that point. And you might even want the same behavior of clamping values between 0 and 1 for many properties in other places in your code. So let's not repeat ourselves, right? So one way to improve that is to create a dedicated type. Let's call it clamped, for example, that will encapsulate that behavior and allow us to reuse that behavior in multiple places in our app. So I create a dedicated type, clamped, that's going to wrap my double value. That's the value that's going to have the specific behavior, like did set here. And then I can really use that type as a property type. Now, progress and volume are not just arbitrary doubles, but they are clamped values. So it's nice because it adds semantic to your code. The API is clear now that it's a clamped value. But what's not so nice is that at call site now, you have to access this .wrap value. You have to create an instance of the clamped struct that you created. So it's nice to reuse this behavior in multiple places in your app. But when it comes to call site, it's not that great. So we're at that point in Swift 4, and we're kind of forced to pick a side between copy-pasting the did set or reusing that in a type, but having this strange call site. And that's where property wrappers come to the rescue. So property wrappers are a new feature provided by Swift 5.1. It's kind of a new superpower. We have learned a lot about superpowers in this conference. That's a new one as well. And what it will allow you to do is to simplify your call site. So we start with the same type that we have, and it's a pretty nice place to start because we have already some reusable behavior. But when you want to turn that into a property wrapper, what's a property wrapper actually? Well, we already have one. Clamped is wrapping a value. So what Swift 5.1 allows us to do is to annotate that type with @propertyWrapper. And as long as you have one property in your struct here, or in your class, if it were a class, called wrap value, you can just create this annotation with @propertyWrapper. So here we have a wrap value of double. It could be anything else, but as long as we have a property called wrap value, it's OK. But then what? OK, we have annotated that struct with @propertyWrapper. It's still a struct that can be used like any other struct, so we can continue to have that code that we have on the slide, creating a clamped instance. But the fact that we now have this @propertyWrapper, Swift 5.1 allows us to have a nice syntactic trigger to express the same idea. So now, because clamped is a struct, but it's also a property wrapper, we can simplify the declaration side and the call side that way. So that's a little bit of magic here. But really, it's just syntactic sugar that the compiler provides us. And now the call side looks very nice because we have movie.progress, not movie.progress.wrap value. And even the declaration side looks nice because we have progress, which are really double values. So we can say progress equals 0. We can access the value as if it were a normal double. But behind the scenes, it's still an instance of clamped. It's just that you don't see it anymore. It's hidden by the compiler under that annotation at clamped. So how does this kind of magic work? It's not that complicated, actually. It really boils down to this magic change that the compiler does, but that's all there is to it. So once you have at clamped in front of your property, the compiler will turn that into declaration of two properties in the background. So when you compile, you will have this exact code generated for you by the compiler. So if you're running with Swift 4, it's code that you can actually already write private var underscore progress and stuff like that. But with Swift 5.1, the compiler will generate that intermediate code, that boilerplate code for you. So what's happening here is that the compiler will still create a variable of type clamped, which will encapsulate all the logic that we implemented ourselves, like the did set clamping the value. But it will name that property with an underscore, like underscore progress, and make it private. And it will make a computed property called progress that exposes the value that we're interested in. So progress is basically just a computed property that is a convenience provided by the compiler to hide the fact that it's actually accessing underscore progress wrap value. So what's happening when you do movie.progress equals 42 is that it calls that computed property progress. If you print movie.progress, it's going to go through the setter, which in fact will call underscore progress.wrap value, and then it's up to the implementation of clamps to do whatever they want with the wrap value, like the did set we have. But once you know, I want this slide to sink in, because once you know that it's this only bit of magic that the compiler does, and you know that it's just transformed in that way, everything falls into place. Because again, our clamped struct that we created, here is just a normal struct. You can still use that and any other struct, so you can make it generic, you can add functions to it, you can add properties to it, like any other kind of struct. So instead of having a property wrapper called clamped that's going to only work on doubles, we can just make it generic and accept a custom range. That way it can be used on integer and on floats, stuff like that. But now we have an implicit init for this struct that's taking a wrap value, but also a range. So we know how to do that if we call clamped, the init of clamped ourselves. Like it's going to be clamped init with wrap value and range. But how does it look when you use the syntactic sugar of the annotation? Well, it's actually pretty easy. We just provide the range parameter as part of the annotation. So what's happening here is the code that the compiler is going to generate an underscore progress property, and it's going to initialize that with clamped init with wrap value equals 0, and range equals the range between 0 and 1. So the magic here is that it's going to call the init, inject the thing that is on the right-hand side of the equal sign as the first parameter, called wrap value, and then everything else that you put in parentheses, like range here, is going to be the remainder of the init. So you can go pretty far with that, and you can provide your custom init the way you want. As long as you have an init that takes a wrap value as a first parameter, you will be also able to use equal whatever, and it will be injected in the wrap value. So that's a pretty interesting example already that you can reuse in your project if you have cloud values. It's pretty flexible because now we have some generic version of it. But there are plenty other use cases you can imagine, like wrapping user defaults. So some of you may be familiar with this kind of pattern, like you have a computed property that will wrap the access to a user default. So for example, when I want to access the username that is stored in my user default, instead of always calling explicitly default object for key, default set of object for key, I have a computed property that does that for me. And that way, it's nice to print name or say name equals whatever. And behind the scenes, it's going to write to the user defaults. So that's exactly the kind of thing that resembles a custom behavior. That's actually a custom behavior we have get and set here. So once again, we have a property with custom behavior of how it's going to be get and set. So that's a perfect use case for property wrappers. So how do we do a property wrapper based on that? We already have the custom get, the custom set, so we just wrap that in a wrap value, and that's it. So that's as easy as it is to create your own property wrapper. You already have probably the code with get and set. All you have to do is wrap that in a dedicated type. So of course here, if I use that way, every property that I'm going to annotate with user default is going to use the hard-coded key. So let's make that more flexible. Transform those hard-coded keys into properties. But again, that's a class. So like we had the struct with range, a class can also have instance properties, custom init, whatever you want. So we can still use it as a regular class. But now that we have this custom init with wrap value, again, because wrap value is the first parameter, and then key, then we're going to be able to use that at call site that way. So again, I'm repeating it to make sure that it sinks in, but this is just boilerplate generated by the compiler behind the scenes. So it's just syntactic sugar. When you write that at call site, the compiler will transform that into a call to init with wrap value Olivier, key, username. So at call site, you'll have something like this, and the compiler will generate those two properties that we talked about. And what's really nice now is that we have a nice API for the main user, because it looks like it's really just a name being a string. But we see that we have this kind of metadata attached to that property, telling it how it behaves with the get and set, and the key attached to it. But what the user of main user will care about, like the developer using that class, is that there is just a name property of type string. It doesn't care that it's backed by user default. But the code that is generated by the compiler here is not just some pseudocode that I put there. It's actually what the compiler generates. It really generates a private var with underscore name and a computed variable of type of name. So that means that there is actually a property called underscore name existing in our code base now. So it's private, so you can only use in the private scope. So for example, in the demo function, but you can totally use it. So if you want to access those kind of metadata that are attached with the wrapper, you can access underscore name. Underscore name, again, is this property created by the compiler of type user default. And user default is the type that we created earlier with a property like name, default value, whatever. So you can access that as long as you stay in the private scope. It's designed that way on purpose because when you then say you make that modular architecture and you wrap all the main user stuff in one framework, you might want to expose main user as having a name property, but you don't want the outside consumer of the framework to know about underscore name. So that's intentional that underscore name is made private. even if name is internal like here, or public, or even private, underscore name is always going to be private. But how can we go further then? Because it's nice to be able to access the wrapper in some cases, even outside the framework or outside a private scope. Well, Swift 5.1 allows us to do that as well. So there is some feature that is optional when you create a property wrapper. You have to create a property to have a property named wrap value. That is the property that you are wrapping. But optionally, you can also have an instance property named projected value. So if you don't want that, you can just not have that in your property wrapper. But if you provide a property like that, the compiler will additionally generate a property with the $sign prefix. So basically, underscore name will be the name of the type of your wrapper. Name will just be a kind of proxy to the wrap value, and underscore name will be a proxy to the projected value. And like wrap value, projected value can be of any kind. So if you want it to be a double or a string or whatever, float boat, you can do whatever you want as long as it's named projected value, and you can make it return whatever you want. So for user default, if I want to have a projected value, probably the most straightforward property that I want to expose as a projected value would be the key, because that's the main metadata that I might want to access. So that's what I decided to do here. But you'll notice that because there is no other requirement that the property has to be named projected value, but that's it, you can put whatever you want here. So be sure when you create your property wrapper to document that very carefully, to explain that for this wrapper that I created, user default, I'm going to run that to other people in my code base. I'm going to document that the projected value of this wrapper is going to be the key. But now that we have that, still we can't use underscore name because it's private, but now that we have a projected value, we can access $name even outside the private scope. So underscore name will always be private. Name and $name will always have the same access level. So if name is internal, $name is going to be internal. If name is declared public, $name is going to be public. So there are plenty of things that we can imagine from there. I only gave you 2 examples in the previous slide with different implementation, but without going into details, I have some homework for you. So be sure to launch a playground and try with all those ideas. Some of those ideas might be about creating a version or undoable property. Basically, the idea is when you set the value, you could have a custom set that will store the value, but will also stack the value, push the value into an array, like an history. And then with the projected value, you can imagine that the projected value would be the history, or projected value would be an object, maybe the wrapper itself, that has an undo function that will allow you to reverse the property. So that's one idea. Explorable would be a wrapper that provides you the behavior like if you access the value after 60 seconds of the set, it's going to return nil. So the custom set will store the value, but also the date, and the get will compare the date, return nil, or return the value. So it's there's a lot of information out there. Maybe it can be just for fun. Maybe it's actually really useful. But there is so many cases you can imagine like that. And again, things like validated works as well, because, well, validated will still be a struct or a class or whatever that's going to have an init with a closure. And a closure is a valid parameter for an init. So for your property wrapper that takes arguments like range or the key for user defaults, those parameters can also be closures if you want to. And of course, with all we saw with this projected value and stuff, that should have reminded you of all you saw with the SwiftUI, talks and classroom, and combine. Now you might, maybe, hopefully, you now understand what's hidden behind add state, add published, and all those stuff. So basically, add state is just a property wrapper provided by SwiftUI, but it's not hard-coded in the compiler. It's just something that's provided by the framework. And the projected value of state happens to be a binding, but the projected value of published happens to be the publisher. So depending on the wrapper you use, the wrapper is going to project the value they want to. That's almost it for property wrapper, but of course, I had to do one more thing, right? We're at a Noble conference, after all. So again, property wrapper, I can stress that out, is mainly to provide custom behavior for your property. But custom behavior can be provided by get and sets, but they can also be provided by conformance to protocols, like Codable or Codable, stuff like that. So now imagine a use case where you have this huge struct. Wait, OK, it's only 4, but imagine you have a struct with 15 properties here, and you're pretty happy with the default implementation of Codable that the compiler generates for you, except for this single property that you want to customize. And now I'm guessing that all of us that played with Codable have encountered that use case. You have to implement init from decoder and encode to encoder manually for all those properties, even if you only want to customize one. But property wrappers can also help on that. Like now we can create a wrapper that sure has a wrap value of dates, but doesn't have any getter and setter on that because we don't really need to change the value when we set or get the date of a property. But the interesting thing about that wrapper, it's going to conform to Codable. So sure, when you create this YMD type, you're going to have to implement Codable yourself for this type, but you're going to just have to implement a single value container storing one single property, the date, converting that to a string, year, month, date, and converting that back to a date when you decode. But that's an implementation that is only like 2 or 3 lines of code just for a single property. And now that you have that for a date, you can just use that annotation on your property, on your single property. So that's really something that's, I find, really cool about property wrappers and something that not many people, even people who knew about property wrapper before, didn't even think about. But now you can imagine that not only we didn't have to implement the whole Codable implementation of movie, which might have 15 properties, but we also have a property wrapper that is reusable. So if we have tons of models, and all those models of custom dates in many places, we can just reuse this YMD every place we want. So of course, you can start from there, and you can create a new wrapper about dates that takes a parameter like the date format and the time format and stuff like that. You can imagine pretty many use cases about that. And there is also similar use case for equatable or case insensitive equatable, stuff like that. That makes the property wrapper even more powerful. So that's it for me. That's a wrap from my talk and for all the talks of the conference. I hope this makes things more clear about what's behind SwiftUI with those add states and stuff, what's behind Combine as well. That's not that much magic, but it's just syntactic sugar after all. And if you want to learn more about property wrappers, I've put some links in there. Don't hesitate to take photos. And that's it from me. Thank you.
Thank you. Thank you, Olivier. Please.
Well, thank you.
So, time for questions.
Yes.
Sure.
But like, yeah, the problem is I'm not really an expert on properties. So
actually, I was working for the conference, so I actually no idea what you talked about.
Maybe we should ask an expert to help us with the Q&A session.
I think so.
Yeah. Do you know a good expert about properties?
No.
Oh, this guy again.
Oh.
Yeah, please welcome.
Come on in.
Always Pradey.
Come on.
That wasn't prepared at all. Actually, we have questions. Do you have like any usage for when the projected value is different than self?
Yeah. So the thing is, when you look at lots of tutorials or articles about property wrappers, there was use case that comes often when they talk about projected value, is that often it's useful to return to make the projected value return the wrapper itself. Like for example, in my undoable or versioned wrapper, to be able to do $whatever dot undo, $whatever will be the projected value, will be the wrapper, and then you implement undo on the wrapper. That's the easiest way to provide functions behind the projected value. So that's a common use case, but actually when you think about it, state doesn't return a state behind the $whatever, it returns a binding. Published doesn't return a publisher, published, it returns a publisher. And even for my example about user defaults, you can imagine $name return the user default struct, and then you'll be able to do $name.key, $name.default value. But if you're not only interested in key, you can directly expose the key itself.
And the idea is really interesting. And do you know, like, where does it come from? Does it originate somewhere else?
The idea of property wrappers?
Yeah.
Yeah, there was a pitch in the Swift Evolution forum. It was called property delegate, if I believe correctly, at the beginning. And it's kind of the idea to add a behavior to a variable in a transparent way for the user, for the developer.
Yeah, totally. So actually, the idea of property wrappers comes from two major proposals. One is about what was called before property delegates and is now renamed property wrappers, to provide behavior, and the other was to bring annotations, because we all love Java, right? Yeah. Annotations to the Swift language. So the proposal about the annotations started to get a little bit complicated, like can we access those annotations at runtime, stuff like that. So they realized that maybe annotation in general is a big topic, but we want to focus those annotations to be property delegates, like the custom behaviors of properties. So they mixed those two ideas, and they come up with something that was a bit of a mess of an implementation first, but it ended up being very nice. Now they simplified that a lot, and now it's just a struct, you annotate that, and it's magic.
Bad coffee or Java?
Still bad coffee.
And what about, I mean, difference between annotations in Java and in Swift? Are we there yet, or what's the gap between what the Java world has to offer and what the Swift world?
We are still in the early process of property wrappers, and it's called property wrappers, not annotations, because they have more ideas for other usage of annotations. So Swift already has annotations built in the language, like at property wrapper is actually an annotation, at auto closure, that you presented is another annotation. So these are those kind of annotations. These are there are the annotations that you can create with property wrappers now. But there are also plans in the future, at least that's what they say in the forums, about using those annotations for other use cases, like being able to use the reflection APIs to know about those metadata. And in Java, you can also add multiple annotations on functions, on properties and stuff. In Swift, you can only, that's property wrapper, so you can only annotate properties. I'm going to come back to that. I sense a question there. And you can also use only one property wrapper per property. So you can't yet compose and annotate one property with multiple wrappers. They thought of that, and again, there was some complexities, so they're going to revise that and come with a solution later. Okay. But yeah, property wrappers can also only be applied on properties and not directly on classes, like Java can be. They can't be applied on functions, but since functions are first-class citizens, you can also create a property that is a closure pretty close to a function, and you can play with that.
My fear with all those kind of new features in a language is that you start testing it, loving it, and then you start putting that everywhere. So do you have some tricks to, like, rules to know when you're going too far?
You've got like a rule of thumb saying, okay, am I going to use it like at least 3 times? If it's less than 3 times, maybe a property wrapper is overkill. If it's more than 3 times, maybe it's cool. And also, am I going to use it in a consistent way for a specific purpose? I think there are 2 cool rules.
A bit
Yeah,
like
that's so. There are those cool rules. There are some rules that we also saw in other talks, like don't make that to generate at first. Start with a simple implementation that fits your need in your application, and then if it's okay, it's enough, and then generate that later. And one other thing is when you design a property wrapper, be as mindful as when you design operators. They are cool, but they're also dangerous to create too many operators. Well, that's the same for property wrappers.
Yeah, or code that is really hard to read. But that's also something I liked about annotations. Is like, you know, versus like the first version of your clamped variables, that it was kind of tricky to know that it's you will set a variable, but what's going to happen then inside? And having an annotation adds readability, I guess.
Yeah, it provides semantic meaning to the property. So when you read at clamp, you already know what it's going to be. If you have this did set, explicit did set at the very first slide, you have to pass in your mind what the did set is going to be. Is it min max or max min? I don't really know. But you have to be careful of the name of the you give to your property wrappers so that they are explicit.
Yeah, it's kind of like when you use map. It's clear that you are doing a transform, but you are also trusting yourself to actually write a transform and not do other things inside the closure. Exactly.
Yeah.
One thing I like about property wrappers is actually that, I mean, even if it's been introduced like these days, it's available for all versions of iOS because it's a Swift version, isn't it?
Yep. So as I said again, it's just Swift syntactic sugar that is generated by the compiler. So all that matters is that you use a proper compiler. As long as you compile with Swift 5.1, then you can reuse the code. Well, you can use that code and ship that for an app that is still iOS 11 or 12.
Okay, awesome.
Thank you very much.